We got quite a bit of notes too. 10.4, graphing data. Now this is the most widely used method. Now here's the thing. This is, you're going to learn how to make a bar graph, line graph, and pie chart. In reality, y'all's computers can do these. They do it for you. They calculate everything. All you do is put in the information and they create what you want. It's that simple, okay? Gone are the days where we do what I'm teaching you today. You need to understand the concept, and that's why you have to learn this, okay? And that's why I said that what I'm considering doing is having you do this project. I'll probably play with it tonight and then assign it. Just because you need to know how to create these bar graphs, line charts, pie charts, whatever, on your computer. It's real easy. But with your Chromebook, you can create it. It's, real easy. You just stick in the information, hit enter, and they create it for you. So it's not a huge, weird project. It could be kind of fun.
On Google Docs, whenever you try to insert a graph, it just randomizes it. It doesn't let you put in the information.
Well, that's why I'm going to have to play with it again. But you can create your own. You're talking about inserting, but you can actually create a graph of your choice. You can change the color. You can change the font. There's all kinds of things that you can do, and it can be a lot of fun. So that's why I said what we can do is create a survey. Y'all go get the information, come back, and then on your Chromebooks, just create 3 different types of graphs. It'd be fun. But I just got to get back. It's been a long time since I've created these graphs. I got to get back in there so I can show you. All right, so we're going to be creating bar graphs, line graphs, and pie charts. We're going to start with the bar or line. Let me tell you, these are way easier than the pie chart. Pie chart I like if I don't have to create it like this. I'm telling you, it's insane. These are way easy right here. All right, bar or line. It's quantity over different time intervals. They also are showing rise and fall of a quantity over time. These can be, now this, talk about when would you use these. Man, you use these all the time. I mean, seriously, all the time. For example, we just had a major freeze. What's been floating around everywhere are line graphs, bar graphs. And what it shows is the history of these freezes. And you can, and so quantity over different time intervals. Time intervals could be years. It could be actual time. Like, okay, another one. You could do a survey or research learning throughout the day. When is the best time to be learning? Do you think right after lunch is the best time to be learning?
No.
For some people it is, some people it's not. How about at the end of the day? By about 3:30, could you be learning algebra at that time? Some people can't. So what you do is if you took a survey of all the students, like in junior high or high school and junior high, ask them when they learn best. You could do a bar graph or a line graph that shows the different times of the day. You could have like time of the day at the bottom, and then, draw the line as to where it's most popular. I found out when I was in college that I'm not a day person, I'm a night person. And someone convinced me to switch to night school. All of a sudden, my grades skyrocketed. I was like, I made perfect scores and everything because I went to night school. I was not a day person. So everyone's different. Another one, like I said, as far as freezes go, there's rumors going around that we're going to have another one that we had, like we had last week, but it's going to be, brace yourself, spring break. It is scheduled for spring break. Now, most of the meteorologists disagree with this. Okay, they disagree with this. If you look at Weather Underground, it shows it. But most of the meteorologists say no, that's too far out, blah, blah, blah. So I decided to look at the history of freezes in March. And there was a line graph. And it showed the years at the bottom, all the years, like over like 100 years or last 50 years. And when we've had actual freezes in March. Very, very few. So that kind of gave me a little bit of hope as far as vegetation goes. So that's what I'm saying. Bar graphs and line graphs, they're actually very helpful to you. Okay, so you kind of need to learn how to deal with them. All right, to do it, step 1, draw and label the horizontal and vertical axis of graph. Draw and label the horizontal and vertical axis of the graph. That's going to be like this. Horizontal, and vertical graph.
Similar whenever you're graphing the dots.
Yeah, exactly. It's going to look like this. For example, if I wanted to, I don't know, do a survey on, and you can actually change it as far as like, it says over time. If I wanted to look at, TV or electronics, I could put electronic usage on this side and time, like by hours or minutes at the bottom. Like an hour, how many people use electronics for an hour? Now, y'all are using electronics right now, right? When you're on your Chromebooks doing schoolwork, that's using electronics, right? Okay. So anyway, it would look something like this. Step 2, choose a scale to fit each axis and make intervals. Choose a scale. Like, is it every 30 minutes? Is it every day? Is it every 10 years, 2 years, 5 years? Choose an appropriate scale. You want one that actually shows time. Like, if I were to survey all the kids in the school about electronic time, I would probably do it every 30 minutes. So I do 30 minutes, and this is a day.
17.
30 minutes, an hour. So I would do it down here, I would put like 30 minutes. The next one would be hour, hour and a half, 2 hours. See what I'm saying? I would put something like that. Okay? That would be an appropriate scale. You don't want to do every 10 minutes because it would be spread out really far right here. You want to do an appropriate one. Step 3, draw a bar for each interval. Or plot points, if you're doing a line graph, and connect them. And then the last step is the easiest. You need to give it a title. You could also do one for eating. Sleeping. How many hours do kids sleep? How many minutes do kids sleep? You could do it, I would do that too, in like 30-minute intervals.
I could probably try to do a graph between comparing the average amount of hours a kid sleeps compared to an adult.
Yeah.
And then I'll probably find, or I might end up finding the kids actually sleep a lot less.
Oh, I am absolutely sure of it. I don't know, because adults, have to go to the bathroom all night long, and we don't sleep good, and we have kids that wake us up and cats that wake us up. So I don't know. All right, pie charts. Y'all got all this down?
Wait, I have a question.
Sure.
So, are the bar graphs the same thing as line graphs?
No, bar graphs have bars. Line graphs have lines.
They have similar ideas.
I don't remember how either of those look.
Okay, if you have your book open, like you're supposed to, you would see pictures of them.
411.
All right, pie charts. And we're about to draw some, so don't worry. Compare how a whole is divided into parts. You can take the same information from all of these. You can take the same survey and create all three of these. Okay, y'all ready? Step 1. And I'm going to put a red star here. Express each quantity to be shown as a percent. Express each quantity that's to be shown as a percent. If I'm putting a star, should you be putting a star, Michael? If I underline a word, should you underline a word? Very good. Step 2, putting another star. Multiply 360 by each percent to get the number of degrees for each category. Okay, multiply 360 by each percent to get the degrees. This tells how big or small each pie piece is. I just spelled piece wrong. Well, I just spelled it wrong again. There we go. I before E, except after C. Okay,
That rule doesn't always work.
I know. Okay. Why are we multiplying by 360? Why 360? Can someone raise their hand? Oh, width. Why?
Because the whole turn is 300.
That's right. A circle. The whole turn or a circle is 360 degrees. So when I say the piece of the pie, for example, how big the piece is going to be. This is how much is going to be shown. Like, let's say 25% of all people get 5 hours of sleep. Well, but we're going to put like 25 here, but we don't know how big of the piece to make it. So we change it to a percent and multiply by 360, and that tells us how big or small to make our puzzle piece. That's why I said there's a lot of calculations here.
Wait, how big the piece is, or how big the stuff that is?
How big we're going to draw it. This right here tells us how big we're going to draw it. And I'm going to show you. Does everyone have this down? Guys, please make sure you're copying all of this down. You are, huh? Yeah. Okay, you got it? All right. Taylor, are you writing all this down? Because I'm marking cards today. If you just sit there and you ask me for help and I say, show me your notes, and you don't have every single thing down, I'm signing y'all's folders every single time. Step 3, you're going to draw a circle the best that you can. 4, label each pie shape piece in words and percents. And then step 5, give it a title. Y'all ready for an example? Make sure you have plenty of space, because the amount of space I have, and I just started this, is going to barely make it. So make sure you have plenty of space. Write nice and neat, because what we're about to write, there's a lot of it. All right, y'all ready? Okay, the first example, we're going to make a pie chart on the study on animal, populations. Animal populations. Okay, let's say you did a lot of research and you found that there's 21,000 cats, that there's 133,000 dogs, that there's 20,500 lizards, and 7,500 hamsters. Shh, Taylor. Okay, so you did research and you found out how many of these 4 different populations, animal populations, okay? So you write down your findings, your numbers. The first thing you have to do is get a grand total. You have to get first a grand total. And the grand total is 182,000. That's your data, or data, however you want to say it. What's the total population of animals that you surveyed or you researched? 182,000. These are the different parts. Now, if you remember, pie charts compare how a whole is divided into parts. This is your whole. These are your parts. Okay? So you collect your data, add it all up so you get your whole. Y'all have this down? All right, back in the front, number 1 says, express each quantity to be shown as a percent. So we want to express all of these as a percent. So we're going to find the percent. Because that's what we want to know. What percent of all of these? This is not what you're putting in your pie chart. Those are big numbers. You want to find the percent. That's what's going to be shown. So let's start with cats. How do you find the percent of the cats? Part over what?
360.
No. Part over the whole. So to find the percent, we're going to divide however many cats. There's 21,000 cats out of 182,000 animals that you survey. You see what I'm talking about? There's 21,000 out of this whole. If you divide it, y'all see where I got 182,000 from? Y'all see that? So we're taking each of these parts and we're going to look at what the percentage is of the whole. So that's the whole. We're going to divide each of these by that whole. And we get 0.11538. But what do we have to do that? Turn it to a
Percent.
So how do I do that? Gabby? That's right. We're going to move the decimal 2 places to the right. And I get 11.5%. But do I want to, but what I'm going to do is round it to a whole. So Taylor, what would this whole be?
12%.
That's right. So 12% of the population that we researched are cats. Do y'all see that? Any questions? All right, let's do dogs. Dogs are 133,000. And we're going to divide that by 100, the whole, 182,000. You get, so I'm doing the math for you to save on time. 0.73. And Gabby said to get percent, we have to move the decimal over, and we get 73%. So right there, 73% of the animal population's dogs, where 12% are cats. Then that kind of make that seems better, easier on the head than, well, 21,000 are cats, 133,000 are dogs. Well, when you're doing pie charts, you're looking at the percentage. All right, how about lizards? We have 20,500 lizards, and we got to divide that by 182,000. And I get 0.11, which would be what percentage, Joanne?
11%.
There you go. Today I will let you use calculators. And the last one is hamsters. We're finding the amount, the percentage, and that's what's going to be displayed or shown on our pie chart. But we're still not done yet. So we're going to divide that by 182,000. And I get 0.04. Izzy, what's the percentage?
4%.
Very good. And I'll let y'all catch up. While you're writing, if there's any questions, let me know. Yes.
Is this going to be on our test because you said we were going to have calculators?
Well, I've got that figured out. I'll probably give you one. Like if I do this, I'll give you one page for the quiz or test that you can use calculators on. When you're done with that, you turn it in, and the other part you can't use calculators on. Yes, Whit?
Can you, for the last part, you just add up all of the things that you've done, and so the last part, you already know it?
What are you talking about?
Like, because the whole thing is going to get 100%, so can't you just add like 12, and it's 73? And
But you don't know these numbers yet.
Well, yeah, but for the last one.
Oh, for instead of multiplying it by 360? I don't know. Because that would give you 100%, but let me show you. So like, how would you know how big to make your pie piece with this? Would you make it 73? Because 100% does not equal a whole pie. Whole pie is 360. Right? Okay, let me show you. All right, so does everyone have this down? All right, so the next thing we're going to do, and I'm going to go to another piece of paper, is we're going to find degrees. This is the next step, step 2. We found the percentage. That's going to be what's shown on your pie chart. Now we got to figure out how big each piece is. So let's start with cats again. What was my percent?
12.
Okay, so when we figured it out, we have 12%. This time we're going to go back to the decimal. And what's the decimal form of that? And now we're multiplying it by 360. And you get 43 degrees. That's how big your pie piece is going to be.
Are we using protractors for this?
No?
So how will we find the...
I mean, you can. You can.
Okay.
You each have one. You can also guesstimate.
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 That's what I call size.
So this determines how big your pie piece is going to be. Let's do dogs. Whoops, I put dogs. Dogs. What was the percent for dogs?
73%.
Change that to a decimal. 0.73 times 360, because the whole pie, the whole circle is 360 degrees. That's why we have 360. 0.73 times 360 is 263 degrees. That's what I'm saying is we're not dealing with 100% here. 100% is correct. That's, you've covered all bases for the pie chart. But to figure out how big the piece is going to be is hard to judge with 73%. So 263 degrees in your pie chart is going to be huge. Lizards was 11%. We have to change that to a decimal and multiply it by 360 degrees. And we get 40 degrees. Notice the cats and the lizards are close. And then the last one, hamsters. They were 4%. Change that to a decimal, we have 0.04 times 360 degrees, and you get 14 degrees.
Why didn't we just leave it like that over here?
Because we got to figure out how big the pie piece looks like. And I'm about to show you that.
Changed it to a percent.
That's going to, let me show you, because I'm about to draw my circle, and then it'll all make sense.
Dog would be.
Hopefully you've got this all nice and neat. So are there any questions? It'll all come together when I draw the picture. Do y'all all understand the steps of finding this stuff?
Sure.
Wait till everyone put your pencil down when you're done copying notes so that I know you've got it all down. Good? All right. Now, to draw my circle. I'm going to draw it kind of big on here so that we understand. Now, if you can't draw a perfect circle, it's okay. Find something in the room, water bottle, that's not very circle-ish.
That's pretty perfect.
But do the best you can. Yeah.
It's too big.
Now, the degrees decide how big or small the pieces are. The degrees tell you how big or small the pieces are. Write the percent in each piece. So your degrees that we just figured out depend on how big we're going to make our pie pieces. The percents that we did right here, that's what you're writing in each slot. Put your pencil down when you're done writing so I know you're done. Why are you just going to start?
Because I was making my circle.
You need to move a little faster. Now, I don't have a protractor, so I'm going to guesstimate. if I did a right angle, how many degrees is that?
90.
90. Very good. So that kind of gives you an idea. If you look at your degrees, that kind of tells you what we're looking at. What is a straight line? 180. Very good. A straight line is 180. So let's start with our biggest one. That's 263. So if a straight line is 180 and a line that goes up and down is 90, what's 180 plus 90?
270 degrees.
Is he right?
Wait.
Gabby, Taylor, what's 180 plus 90?
270
Aiden, is he right? Gabby, is he right? You're correct. Okay, so 270 degrees would be a straight line plus this. So this whole thing would be 270 degrees. Is that kind of close to this? Yeah. So we could do maybe a little less. And that would be, this whole thing would be 263 degrees. So if this whole side here is 263, do we write 263 in this piece? What do we write in here?
The percent.
Oh, okay, I heard two correct answers. Cecilia said dog, and Whit and Aiden said percent. You're both correct. This whole section is 73%, and we write dogs. That's how this is done. Is it all coming together now, hopefully? So you decide how big the puzzle or the piece is by the degrees. Then you write in here the percent and the name. Now the next, so we've gotten that one done. Now we have to figure out these three. So they all have to fit in here. 43 and 40 is close to what? If you add it together, what do you get?
83.
83. Straight up and down is what?
90.
What is half of 90?
33. 54.
Are y'all serious? Gabby? 45. So, if this is straight up and down 90, this right here would be 45-degree angle. What's close to that?
43.
43. So I'm going to make a little bit less and call that cats. What do I write in here?
Cats and the percent.
That's right. Cats and 12%. So we got that figured out. Then the last two is 40 and 14. So again, you're guesstimating. I'm going to probably go ahead and do this as the 40, and that's going to be 11%. That's going to be your lizards. I'm going to do Liz. And then hamsters are going to be right here. I'm writing 4%, and I'm going to draw an arrow and put hamsters or ham. And that's okay to draw arrows. And that's how you do these. Now this is exactly how you do it. You will have a protractor that can help.
There's a lot of dogs. I think that cats and dogs are actually pretty similar. Yeah. Is this pet owner's animal? Like,
I don't know.
I'm pretty sure there's more cat species than dog species. Cats not.
Not
But the
species.
population as well. So there's two factors.
Well, they'll be around the same.
Species and
Lions, tigers.
Those aren't cats.
they're cats. They're not like the cats that we're talking about.
Yeah.
But then
These are domesticated cats.
Okay.
These are on here?
Yeah, that's what we're talking about.
I
Not
think
the
dogs
lions and
cats are
tigers
so
and bears. Oh
not
my.
that much.
But then there are those people that are like they want
Unless you're
tired.
in Alaska.
All right, come on, y'all. Y'all are overthinking it. Are there any questions about this?
Nope, unless we're in Alaska.
What?
Unless we're not in
No.
Hey guys, I asked if there's a question about this. We're not talking about Alaska or tigers and anything. Come on. Again, you will have protractors. They will help tremendously. But again, I did some really good guesstimating here. If you guesstimate and it's appropriate, and if you're good at guesstimating your degrees on a circle, then you're good.
I'm gonna try to
But if you are like, man, I don't know how she came up with some of that stuff, get out your protractor. Y'all are all taught. Taylor.
I'm gonna try to put guesstimate into the Urban Dictionary.
Great.
Okay. Are y'all ready? Let's move on. Y'all got this?
Yeah.
Open up your book. Page 415. We're going to just jump in and start doing some examples. And then I'm only going to do a couple and setting you free. Because some of this stuff y'all have done in your life, reading charts and stuff like that. If you look on page 415, you see a line graph. Do you see that for numbers 6 through 10? That's what a line graph looks like. Y'all have seen those before. Y'all have learned about these. So we're going to skip that. We're going to go down to number 14. It says make bar graphs for the following data. Now, I want you to look. 14, what does it say right next to the number 14, Cecilia?
Using increments of 5.
Okay, use increments of 5. I'm going to write on here increments of 5. And I'm going to explain what that is. When they say increments of 5, they're talking about the numbers. So if you look, it says enrollment by classification. That's how many people. You have your class, freshmen, sophomores, juniors, seniors, and then enrollment, 45, 37, etc. The increments of 5 are going to be used for that enrollment there. Okay? Now, for bar graph, let's see, how did they want it? Okay. It doesn't matter which side you have the numbers. It can be on the bottom. It can be along the top. It doesn't matter.
Can it also sometimes be on the side where the bars go left or right?
That's right. In fact, let me just show you. I'll just show you instead of drawing it out. Y'all can draw this. So you write this on your thing. Here's my title, enrollment by class. I drew the two axes, the horizontal and vertical. Here's my enrollment, because it says right there in your book, enrollment, and it said increments of 5. I started at 0. Does everyone see that? And I went 5, 10, 15, 20, 25, 30. That's what increments of 5 mean.
Oh, I get it.
Okay, does that help?
Yes.
Increments of 5. If they had said increments of 10, Joanne, how would I have done this?
10, 20, 30.
Exactly, 10, 20, 30. We would have gone 0, 10, 20, 30, etc. So they told you what the increment should be. Sometimes they don't tell you. You just got to guess. You got to figure out what's best. So you start with 0. My increments are 5 because they told us, so I have it going by 5s. And then down here is my class. And again, I'm going by number 14, what they have. Freshman, sophomore, junior, and senior. And I drew my bars. So if you look, freshman's at 45. So this bar goes to 45. Does everyone see that? Look at your book and knowing where to put all this stuff. And know why I put the bars where I did. Junior, there's 32 juniors. So 32 is somewhere between 30 and 35.
Wait.
So see, I have that bar right there. It's between 30 and 35. I'll let y'all continue writing. When you're finished, put your pencil down, so I know you're done. Now, if you are not looking in your book at the information they gave you as far as like seniors and everything, and you're just blindly copying from my notes here, then you're going to be in a world of hurt later on. So before you draw your bar, look in your book and see, okay, seniors, they say there's 34 seniors. This is why Miss Rogers has her bar graph go right here, because it's close to 35. Y'all see that? Any questions?
Oh, are we supposed to go to the next page?
That doesn't matter.
Okay.
You got it, Joanne? All of it? Okay. Now, Taylor mentioned you could have it go the other way. Now, let's look as, okay, so like some of you, and I'm surprised y'all didn't ask, how did you know to put enrollment here and class down here? Does it tell you that in the directions? No, it absolutely does not tell you where to put the numbers and where to put, they didn't tell you where to put either one, right? So what if I accidentally or chose to put class on this side and the enrollment numbers on the bottom? That's how it would look. You don't have to draw this, but you can if you want. But notice how it's different than the one you just drew in your book. Emily, are you watching? Okay. So this time enrollment's on the bottom and the class is on the side, but look at the bars. This time they're not going up and down, they're going sideways. Guys, this is okay. It's still a bar graph. It's a horizontal bar graph. Your book has it done this way. But guys, if you were to start drawing it because you have no idea and it started going this way, it's okay. It's not wrong. I absolutely would not count this as wrong. Do y'all see the difference?
This looks hard. I'm like trying to.
Do y'all see the difference? Okay. So let's move on. Well, you need to be writing when we're writing. Okay.
I was.
Let's look at 18. I'll let you look at it in just a minute. Let's finish these. $18. 18 says use increments of 5, and we're making a line graph this time. and increments of 5 with the origin at 0 and 30. Increments of 5 and the origin at 0, 30. That's a very weird way of saying, y'all ready? Do it like this. So 18, here's my increments of 30. Increments of 5 starting at 30 because they said 0 and 30. Now, this is an ordered pair, correct? This is your X, this is your Y. Isn't this your Y-axis? So the Y is starting at 30. Do you see how that goes? And then increments of 5. 30, 35, 40, 45, 50, etc. Do y'all see that? Now this says X is 0. Well, this would be 0, 1, 2, 3, 4, and 5. Do y'all see that? Y'all see that? All right, draw it. The first column there says home game is, and look, did y'all notice? Real quickly, did y'all notice? Whoops. You see, what is that right there?
X.
Look in your book. It's an X, right? And right here, what is that? So in this case, they tell you what goes on the X-axis. Home game. So see, isn't that nice? The bar graph didn't tell you that. This one does. Home game numbers are going to be your X. That's down here because this is your X-axis. And, whoops, sorry. This is your Y-axis. Do y'all see that? If you do not, you need to let me know now.
Where did we get 1, 2, 3, 4, 5?
Okay, so if you look right here.
Oh, okay, I see.
Okay, do you see that? Okay. And that's where that 0 comes from. They're wanting you to start at 0. So they're saying, 1, 2, 3, 4, 5. Does that make sense?
Wait, start at 0.
This would be 0, 1, 2, 3,
Oh,
4.
yeah.
Okay, you got it. Those are good questions. Anyone else have a question about where they're finding this? Everyone have it? Okay. Take your time. Because what we don't finish right now, we'll just finish after Spanish. We don't have a whole lot of science to do today, so we can dip into science
So
today.
this is a pie graph. What's
Yes.
that?
You tell me.
This is a line.
That's right. Very good. When you're done, put your pencils down so I know that you're done.
Oh my gosh, I keep breaking this leg.
You got it, Joanne? You almost done?
Yes.
Okay. I'm gonna pause the video. We're pretty much done anyway.